Every time you hit the back button in your browser, you're using a data structure most developers can define but couldn't explain if their life depended on it. It's called a stack, and it's quietly running behind almost everything you click, undo, and navigate every single day. Stacks are one of the simplest data structures in this entire course, but they show up everywhere once you know what to look for. Browser history, undo functionality, even how your code itself runs behind the scenes. Let's break down exactly how they work. A stack follows one simple rule. The last thing you add is the first thing you remove. Think of a stack of plates. You place new plates on top, and when you need one, you take from the top too. You can't grab a plate from the middle without knocking everything above it off first. Stacks only really need two operations. Push adds a new item to the top. Pop removes the item from the top. Both of these are O1 instant because you're always working with the top item only, never searching or shifting anything else. Here's the real mechanic. Every page you visit gets pushed onto a stack. Hit the back button and the current page pops off, revealing the one underneath it, which was the page you were just on before. That's why back button navigation always retraces your exact path in reverse, never randomly. Every action you take in a text editor or design tool gets pushed onto an undo stack. Hit undo, and the most recent action pops off and gets reversed. This is exactly why undo always reverses your most recent change first, never an older one, no matter how many undos you've already used. Here's the one most developers never think about. Every time your code calls a function, that function call gets pushed onto something called the call stack. When the function finishes, it pops off. This is also exactly why deep, uncontrolled recursion eventually crashes with a stack overflow. The stack of pending function calls simply runs out of room. Here's what trips people up. Assuming you can access or search stack items freely like an array. You can't. A stack only ever lets you interact with the top item. If you need to see or grab something in the middle, you have to pop everything above it first. That restriction isn't a limitation, it's the entire point. It's what makes push and pop guaranteed O1 every time. A stack follows last in, first out. Push adds to the top, pop removes from the top, both O1. Browser back buttons, undo functionality, and even your code's own function calls all rely on this exact same structure running quietly underneath. This is video 9 of the full DevVerseX Data Structures and Algorithms course. Subscribe so this keeps building in order. Next up, Q's Explained, the data structure behind literally every line you've ever waited in, and the mirror opposite of what you just learned.